Welcome to another episode of Software Explorations, Concept and Overviews, hosted by your truly tech coach Ralph, where we are engineered to win. There are no days off. Let's run it up. We got work to do. All right, so let's get to it. We're going to be getting into part 2 of Kubernetes. We did part 1 last week, and it was really, really massive. And I said, you know what? We're going to have to break this down into 2 parts, maybe even 3 parts. I did want to get into the different the core objects and resources, as well as some advanced objects and resources in Kubernetes today, so that we can get so once we actually get hands-on with Kubernetes, we have a much better understanding of what it is that we're working with. And we can, so now, like, when we start using these, doing the work, and it's like, okay, I remember what a pod is, I remember what a node is, and because right now it's a lot of information, it's a little bit abstract, but breaking it down, we're going to have a much better understanding once we get our hands dirty, right? But before we go any further, do me a big favor. If you are new here and you haven't subscribed to the channel yet, do me a big favor. Click on the subscribe button right now. We are going to be doing some great things. So like this video, share this video, subscribe to the channel, hit the notification bell so you know every time we go live and drop new content, which we drop a lot of content. We go live a lot over here because there is so much to learn, so little time, but we are here to win, all right? And if you need additional exclusive content that you will not find here on YouTube, videos like me updating my resume, live from me updating my resume, seeing our latest sprint review, seeing the full Scrum night, as well as having the opportunity to work with me one-on-one for coaching, being part of the Tech Barbarians group. Go over to techcoachralph.dev, sign up today. You can sign up for free, get access to exclusive content, different, a lot of stuff, and it is well worth it. So definitely go over to techcoachralph.dev, sign up today. But with that being said, let's get into the plans for today. We're going to be diving into Kubernetes, so let's get started. All right, so our topic for today, Kubernetes, we're going to take a deeper dive. So let's get to it. All right, so quick recap from part 1. We spoke about what is Kubernetes, why Kubernetes is important, like why use it. We went over like the core concepts. We did the architectural overview. We spoke about how Kubernetes works. We talked about Kubernetes in action, and then we did some key objects and resources and challenges. And then what are the challenges, which we're going to get deeper into today. And then we went into what is the we wrapped it up with that. All right. So what we're going to be doing today is we're going to be looking in depth into the core objects and resources. We're going to look at the advanced objects and resources. We're going to break down the different challenges that people have with Kubernetes, and then we'll be going over, like, exploring the best practices for Kubernetes. All right, so let's get to it. So the core objects and resources. So we went through these core, like we listed the core objects last week, but I want to break down each of them one by one as we get to it. Okay, so let's just go through the list real quick again. Pods, nodes, namespaces, deployments, replica sets, services, config maps, secrets, volumes, and ingress. All right, so we're going to break each of them down one by one. So pods. Pods, the smallest and most basic deployable unit in Kubernetes. A pod represents a single instance of a running process in a cluster. What's the purpose of a pod? Pods typically contain one or more tightly coupled containers that share the same network, namespace, and storage. They provide a shared context for running containers. So as we continue to go through the different resources, we'll get a better understanding of what all of this means. So nodes. A node is a worker machine in Kubernetes, either physical or virtual, that runs containers. So from what I'm seeing here, a pod runs on a node. The purpose of a node is it hosts pods and provides necessary resources, CPU, memory, storage for running containers. Each node runs critical components like the kubelet, an agent that communicates with a control plane. Kube proxy handles networking, and a container runtime, i.e. Docker container D. All right. So what's a namespace? A namespace is a virtual cluster within a physical cluster, providing a way to divide resources amongst multiple users and teams. The purpose of a namespace is to allow resource segmentation, enabling isolation, organization, and management of resources in large clusters. Each namespace has its own set of resources, pods, and services. So pods and services are part of namespaces. Deployments. Deployment is a controller that provides declarative updates for pods and replica sets. The purpose of deployments is to manage the desired state of applications by defining how many replicas of a pod should be running, rolling updates, and rollbacks. It is commonly used for stateless applications. Next up, we have replica sets. So a replica set is a controller that ensures a specified number of pod replicas are running at any given time. The purpose of replica sets is to guarantee high availability and fault tolerance by maintaining a consistent number of replicas, even if some pods fail or terminate. So pretty much my understanding of what the replica set is to have like a fallback. If something fails, we have something for it to fall back on to pick back up so that we do not have, so we can limit the amount of downtime. That's my understanding. I could be totally wrong, but that's my understanding from what I'm reading right here. Services. So it's an abstraction that defines a logical set of pods and a policy for accessing them. The purpose of a service of services is to expose pods to other pods, internal clusters, resources, or external clients. They provide load balancing and a stable IP for accessing a group of pods. And the config map is a key value store for non-sensitive configuration data. So if you're not like trying to use passwords and stuff, like let's say you're trying to say, all right, the logging level should be 1 or 2 or 3 or whatever, like something that's not sensitive, it would go into the config map. The purpose of the config map is to provide a way to decouple configuration from configuration data from container images, allowing dynamic configuration without rebuilding or redeploying the application. So you configure the configuration data in these config maps, and then the application is able to get it from there. And you don't have to always redeploy your container over and over and over again. So config maps. A config map is a key value store for non-sensitive configuration data. The purpose of config maps is to provide a way to decouple configuration data from container images, allowing dynamic configuration without rebuilding or redeploying the application. So pretty much, you have this config map that has like data that's like maybe logging level, things that aren't going, like if they get out, it's not going to cause catastrophe, right? And that's how you're able to get into the container without having to redeploy. Now, secrets. So it's a secure object for storing sensitive data like passwords, tokens, or API keys. The purpose of secrets is to protect sensitive information and are stored in encrypted format, ensuring they are not exposed in plain text, which that is a big cybersecurity no-no. You don't want secrets being exposed, like passwords and stuff like that, being exposed in plain text. Volumes. So a volume, I guess similar to the volumes on Docker, but it's a storage resource that containers within a pod can access. Volumes provide persistent or ephemeral storage for containers, allowing data to survive container restarts or to be shared between multiple containers in the same pod. So that's exactly how Docker uses volumes, where you can have one volume that it's independent of a container being restarted, and you can have multiple containers reading and writing to the same volume. Ingress. So that's an API object that manages external access to services, typically HTTP. The purpose of Ingress is to provide load balancing, SSL termination, and name-based virtual hosting for Kubernetes services. It acts as a gateway for managing external traffic into the cluster. So there are some advanced objects and resources that I would also like to go over. And let's just go through the list real quick, and then we'll go into each one of them one by one. So stateful sets, daemon sets, jobs and cron jobs, persistent volume PV, and persistent volume claims PVC, horizontal pod autoscalers HPA, and then network policies. All right, so we're just going to go through each of these to get a better understanding of what they are, so that we can be well informed. So stateful sets is a controller for managing stateful applications like databases. The purpose of stateful sets ensures that pods have unique stable identities, persistent storage, and consistent networking. They are used for applications where each instance needs to maintain its state or identity, so such as database nodes. A daemon set is a controller that ensures a copy of a pod runs on all or selected nodes in a cluster. The purpose of a daemon set is used for making background services or agents that need to be present on every node, such as a log collection, monitoring, or network services. And I'll tell you this, like all of this stuff is so new and foreign to me. I am learning it with you. Like I put together the presentation so that I can get a better understanding of as we go through it. And I hope it's helping you as well. But I know that we have a lot of work to do to get a better understanding of this, right? Jobs and cron jobs. Jobs. So the definition of jobs is it's a resource for running batch or one-time tasks until they complete successfully. The cron jobs is a resource for running jobs on a scheduled basis, similar to cron in Unix and Linux. So yeah, pretty much cron jobs is you put a job on a schedule, right? You put it to work. So the purpose of jobs and cron jobs is to manage short-lived tasks and recurring jobs, ensuring they run to completion on a defined schedule. So persistent volumes, PV, and persistent volume claims, PVC. So the PV is a cluster of wide storage resources representing physical or cloud storage. The PVC is a request for it's a request for storage by a user that binds to a persistent volume. So so the purpose of the PVs, the persistent volumes, and the persistent volume claims is abstract. It abstracts the underlying storage implementation, providing a standard way to request and to consume persistent storage for pods. So pretty much stuff to do with how you get access to the data inside of these like it just keeps it up, right? So horizontal pod autoscaler. So that is a controller that automatically adjusts the number of pod replicas in a deployment or replica set based on the observed CPU utilization or other select metrics, right? So pretty much it's pretty much saying like, do we need to increase or decrease the amount of pods that are being ran in order for this application to run successfully? It sounds like it would be very that's what you'd be using on a very large of enterprise level software. The purpose of HPAs ensures that applications scale dynamically based on workload demand, optimizing resource usage and performance. So network policies, it's a set of rules that define how pods can communicate with each other and with other endpoints. The purpose of network policies is to provide fine-grained control over the network traffic, allowing or denying connections based on labels and selectors, enhancing security within the cluster. So now that we go back to this right here, so the architecture that we looked at last week, so we have this, so the way that you get into Kubernetes, you have the UI of Kubernetes, you have the API, and then you have the CLI. Then we have this master, which I'm guessing would be the control plane over here, control plane. And then we have node, and the kubelet with the worker. And then you have the different nodes over here. So let me see. So if we just can't go back that way, but I'm just wondering like how I can't wait until we actually get to work on this, because I'm trying to figure out how the nodes fit in here. Like what exactly is the pod that we read about the kubelet. But yeah, this is going to be very interesting to get to like, once we're working on it, we can probably reference back to this presentation to say, okay, this is exactly what the node is doing. This is exactly what the pod is doing, but we're going to figure it out. So what are some challenges when getting into Kubernetes, right? So there's the complexity of setup and management, the steep learning curve, resource overhead, security complexity, networking and storage challenges, monitoring and observability. I always have trouble with that word. Continuous integration and continuous deployment, CI/CD complexity, difficulty in debugging and troubleshooting. So let's get into that. The challenge for the complexity of the setup, right? Kubernetes has a very steep learning curve, which I can see that already because it has so many different I thought Docker was hard when I first used it, but this seems like crazy, right? So it has a steep learning curve and it involves many components such as the API server, the etcd, the scheduler, the kubelet, the kube proxy that needs to be correctly configured and managed. Setting up a Kubernetes cluster from scratch can be complex, especially for those new to container orchestration or distributed systems. The impact of this complexity can lead to configuration errors, inefficient resources use, and difficulty in troubleshooting issues. This makes it harder for teams to quickly adopt and effectively use Kubernetes, right? So I think if a team wants to adopt Kubernetes, they need a very good leader who understands it and who's patient and who because not only that it can be difficult to adopt, it can be very costly to your company if you set it up incorrectly, because you'll be wasting a lot of resources. So the steep learning curve, the Kubernetes, so the challenge is that Kubernetes introduces a new set of abstractions and terminologies, i.e., pods, deployment services, replica sets that require time and effort to learn. Understanding how these components interact and are configured can be overwhelming for beginners. The steep learning curve can slow down the adoption of Kubernetes within teams, increase the time needed for training, and potentially lead to misconfiguration or poor utilization of the platform's capabilities, which is definitely understandable, definitely true. So there's also resource overhead, right? Kubernetes itself requires resources to operate, including CPU, memory, and storage. It adds an additional layer of infrastructure that needs to be managed, which can increase the overall resource consumption of a cluster. So the impact is for small business applications or environments within limited resources, the overhead introduced by Kubernetes may outweigh its benefits. This is especially challenging for on-premises deployments or edge computing scenarios with constrained resources. So there's also a security complexity to this, right? So Kubernetes introduces several security concerns, including securing the cluster's API server. So that means people from the outside can't access to it. People from the inside who don't have authorized access, they also shouldn't be able to access it, right? So managing access controls, handling container vulnerabilities, and protecting sensitive data like the secrets. Each of these aspects require careful configuration and monitoring. The impact of not doing this correctly is improperly secured Kubernetes clusters can be vulnerable to attacks such as unauthorized access, data breaches, or container escapes. Ensuring a secure Kubernetes environment requires expertise and constant vigilance, which can be challenging for smaller teams or organizations without a dedicated security team. Yep, makes sense. Network and storage. So the challenge that network and storage brings to Kubernetes is that networking can be complex, especially in multi-cluster, hybrid, or multi-cloud environments. Configuring network policies, service discovery, load balancing, and ingress can be daunting. Similarly, managing persistent storage across different environments and integrating with various storage solutions can be challenging. So something I'm thinking about is like when you think about storage units or maybe apartment complex, trying to like storage units, for example, getting access to that storage unit, and then there are many people who have access, and then there's going to be different, for lack of better terms, containers, which would be those actual storage units, right? So you have the, let's say, public storage, where once you get inside the gate, now you have all these different little storage units, and different people have access to it. So getting all that infrastructure and that network together, the same way if you have an apartment complex with the electricity and the plumbing, getting that separated. So now bringing it back to Kubernetes with the networking and the storage, all of that can be very complex thing to figure out. When we talk about like with Docker, and we just have, we have this one container, we have this volume, we have this network, and how they interact together. Now, when you're putting that out on Kubernetes, that's going to be at a much bigger scale, which I can definitely see how that can be complex. So misconfigured networking or storage can lead to performance issues, application downtime, or data loss. Understanding and managing the intricacies of Kubernetes networking and storage requires in-depth knowledge and experience. And I'll tell you this, right? Data loss is such a company killer, right? Losing customer data can just be the end of your company, because with performance issues and application downtime, those are really bad, but there's ways around that. But when you start losing data for customers because you have misconfigured networking and storage stuff, that can just take everything under. So monitoring and observability, right? So have so much trouble saying that word, but the challenge is that monitoring and observability in a Kubernetes environment can be complicated due to dynamic nature of containerized workloads. Traditional monitoring tools may not provide sufficient visibility into Kubernetes components or container metrics. The impact of this is that a lack of proper monitoring and observability can make it difficult to detect, diagnose, and resolve issues in a timely manner, potentially leading to application downtime or degraded performance. Integrating tools like Prometheus, Grafana, or FluentD adds extra complexity and requires expertise. So we had set up Grafana and Prometheus a while back when we were doing some cybersecurity work. But so it's going to be very interesting to see how we can integrate that to see into our Kubernetes environment once we get that set up. But yeah, I mean, I can definitely see like monitoring is so important, because if we don't have the right metrics, we don't know what we're doing. We don't have good insight. So very important. Continuous integration and deployment. So the challenge with setting up a CI/CD pipeline for Kubernetes can be complex, especially when dealing with multiple environments, microservices, and various deployment strategies. For example, blue-green canary deployments, integrating Kubernetes with existing CI/CD tools and managing configuration across multiple environments can be challenging. So the impact of this is inefficient or poorly configured CI/CD pipelines can lead to deployment delays, errors, and inconsistencies between development, testing, and production environments. And you guys know the longer we take to get to production, the longer it takes for us to make money, and time is money. So getting a good handle on that is going to be very important. So we're going to as we learn this, we're going to figure out how to overcome these challenges so that we can be in the best position to win. So debugging and troubleshooting. The challenge is troubleshooting issues in a Kubernetes environment can be challenging due to its distributed and dynamic nature. Logs, metrics, and traces are often scattered across multiple containers, nodes, and clusters, making it difficult to pinpoint the root cause of an issue. The impact this has is time required to debug and resolve issues can increase, impacting developer productivity and potentially lead to longer downtimes, which that's just, that's a disaster right there. So, and then we also have the challenge of managing stateful apps. While Kubernetes is designed for stateless applications, managing stateful applications like databases can be more complex. Ensuring data consistency, persistence, and recovery in the event of failures requires careful planning and configuration. The stateful applications that may require specialized knowledge and custom configurations, making it harder to achieve the same level of resilience and scalability as stateless applications in Kubernetes. So, something for us to be aware of. The other thing is that the upgrades and version compatibility. The challenge is that keeping Kubernetes clusters up to date can be challenging as it requires careful planning and execution to avoid downtime and incompatibilities. Different components and tools in the Kubernetes ecosystem, such as Helm, ingress controllers, they must be compatible with the cluster version. So that's definitely something to take into consideration. I've seen so many times when working on just developing things, and we see that the different packages are not compatible with each other. So now this is when we're referring to infrastructure and DevOps, this can definitely be a roadblock, right? So the impact is that upgrades can be time consuming and risky, potentially leading to service disruptions if not done correctly. Organizations may delay upgrades, leading to security vulnerabilities or missing out on new features. And I wonder how many times that we've had a bug bite episode because we couldn't upgrade. We had to delay upgrades because of whatever the reason is, which then leads to different vulnerabilities and people getting hacked and stuff like that. Lack of skilled personnel. So this is another challenge because maybe Kubernetes is not the biggest widespread tool, and so it's very challenging, as we can see so many different features about it, right? So the challenge is that Kubernetes is still relatively new technology, and there is a shortage of experienced professionals with expertise in managing and scaling Kubernetes clusters. So with that being said, if you see that this is a challenge, maybe you should dive deep into Kubernetes so that you can become a Kubernetes expert. Do many different projects so that you can and you figure out a way to overcome all these challenges, because you will probably be in high demand, right? Organizations may struggle to find or train personnel with the required skills to operate Kubernetes effectively, which can lead to operational inefficiencies or misconfiguration. So that is your opportunity to conquer the market. Right. So let's get into some of the best practices for Kubernetes. We'll go down the list and then we'll go through each one of them one by one. So design and organize your cluster properly, optimize resource management, secure your Kubernetes cluster, use config maps and secrets properly, keyword emphasizing on properly, monitor and log effectively, plan for high availability and disaster recovery, manage deployments and rollouts properly, optimize storage and networking. So pretty much everything that I said was a challenge is pretty much saying figure out how to do it right. And some more best practices: perform regular audits and security scans, very, very important. Use GitOps for configuration management, automate repetitive tasks, test and validate configurations, clean up resources regularly, documentation and knowledge sharing, stay up to date with and engage with the community, right? So we went through all the challenges, and this list is pretty much telling you how to get around all those challenges and the things that, like, as we're learning Kubernetes, what we need to focus on, what we need to highlight, so that we can be in a good spot. So like if we end up going in for a job where we'll be managing Kubernetes environments, we're already on the right track. And this also leads to like the type of like when we're doing these projects, we need to take all of this into consideration so that we can make sure that we're learning it the right way. So let's get into it. Design and organize cluster. Use namespaces for organization. So use namespaces to logically separate and isolate resources within your cluster. This is particularly useful in multi-team environments or for separating production, staging, and development environments. Label and annotate resources. Use labels and annotations to organize and identify resources. Labels help with selecting and grouping objects, while annotations provide metadata that can be useful for auditing, debugging, and operational purposes. Optimize resource management. Set up resource requests and limits. Always define resource requests and limits, CPU and memory for your pods. This ensures proper scheduling, prevents resource contention, and protects the cluster from overconsumption by any single pod. So think about it as protecting, like, because at the end of the day, right, costs matter. You don't like, so we need to protect the cost. So having our resources scaled the right way. Use autoscaling. Implement horizontal pod autoscaling HPA to automatically scale pods based on metrics like CPU or memory usage. Consider using cluster autoscaler to dynamically adjust the number of nodes in your cluster based on demand. So pretty much, if the CPU gets to like 60 or 70, then we say, okay, we need to add an additional pod so that we can be at good working levels and we don't like burn the system down. Secure your Kubernetes cluster. Implement role-based access control, so RBAC. Use role-based access control to restrict access to Kubernetes API based on user roles. Define roles and role bindings to enforce the principle of least privilege, limiting users and applications to only the permissions they need. Use network policies. Define network policies to control traffic flow between pods, namespaces, and external endpoints. This helps to enforce security boundaries and protect sensitive services. Lastly, keep your cluster up to date. Regularly update Kubernetes and its components to the latest stable version to benefit from security patches, new features, and performance improvements. But you also got to make sure that you also have to make sure that what you're using within those clusters, that the versions are compatible and things like that. As we read, it's part of the challenges. So that's another whole headache right there. Use config maps and secrets properly. Store configurations in config maps. Use config maps to decouple configuration data from container images, making it easier to manage configurations across different environments without rebuilding container images. So pretty much, you like when it says to decouple, that means you don't have the configuration information inside the actual containers, because now if you need to make an update, then you have to redeploy and rebuild the whole container. That is not the best way to do it. You need to have it externalized. Manage sensitive data with secrets. Store sensitive information like passwords and API keys and secrets. Avoid hard coding sensitive data in container images or configuration files. Ensure that secrets are encrypted at rest and in transit. And I'll just give you a quick story. In the quotes application that the tech barbarians were building, I ended up getting a collection name for the MongoDB hard coded inside of our model. And when I was migrating it to a microservice, like the test would not pass for some reason, and it took me like almost a day to figure out that was the issue. That we had some hard coded collection name in there, and then once I externalized it and I used the environment variable that it should be, then everything worked right away. So you got to be really, really careful. Make sure that using config maps, do not hard code anything. Next up, monitor and log effectively. Implement monitoring and logging tools. Use tools like Prometheus for monitoring and Grafana for visualization to keep track of cluster health, performance, and resource usage. Use FluentD or another logging solution to collect and centralize logs from all pods and nodes. Use readiness and liveness probes. Define readiness and liveness probes for your pods to help Kubernetes determine if a pod is healthy or needs to be restarted. This helps maintain application availability and ensures self-healing. So pretty much from what I'm understanding with this is setting up a health check to see like what is the like how is our CPU usage, how is our pretty much the health of the application or the health of the cluster or the health of the pod, so that we can know if we need to add more, if we need to restart, if we need to scale down, things of that nature. The next best practice is plan high availability. Use multiple availability zones. Deploy your cluster across multiple availability zones to ensure high availability and resilience against zone-specific outages. Configure your load balancer to distribute traffic evenly across all zones. Also implement backups. Regularly backup etcd, the key value stores that hold the state of the Kubernetes cluster to protect against data loss. Use tools like Velero or backing up Kubernetes resources and persistent volumes, right? So this is pretty much protecting your infrastructure, because if things get out of whack, then you are going to be in deep trouble. And when you never know, your application might be featured on the news or on some type of YouTube channel, and now you have tons of people flooding your application, and you're not prepared to handle it. So you definitely want to be available to scale up as necessary and to have good backups available. Manage deployments and rollouts. So use rolling updates and canary deployments. Use rolling updates for zero downtime deployments by gradually replacing old pods with new ones. For critical updates, consider using canary deployments to test changes with a subset of users before rolling out cluster-wide. So pretty much this is a deployment strategy where you want to have as minimal downtime as possible. And with the rolling updates, so that means let's say you have a total of 10 pods, right? So you take one pod out and you put one pod in, and while the other ones are still running, and then you continue to you take some out and you put some in, so that by the time that everything is updated, it's all the new features. There's no downtime, so your users don't even notice that there's a deployment happened. Also, you can also test a subset of those on a specific on a percentage of users, so that if something does go wrong, you can roll back while the majority of users aren't affected. Leverage Helm for application management. Use Helm charts to package, configure, and deploy applications on Kubernetes. I've heard of Helm charts, but I'm just not familiar with them yet. So definitely something for us to look into. This provides a standard way to manage application releases and make it easier to version, upgrade, and roll back applications. Optimize storage and networking. Use persistent volumes for storage. Use persistent volumes and persistent volume claims to manage persistent storage needs, and choose the appropriate storage class. For example, solid state drives, HDD hard drives, based on performance and cost requirements. Leverage ingress controllers. Use ingress controllers to manage external access to service, including SSL termination, load balancing, and name-based virtual hosting. Consider using reliable ingress controllers like Nginx or Traffic. Perform regular audits and security scans. So regularly audit Kubernetes resources. Use tools like kubectl, audit to RBAC, or external auditing tools to regularly check the permission and access control configurations of your Kubernetes resources. Perform security scans. Regularly scan container images for vulnerabilities using tools like Trivy or Claire. Ensure that all container images, including those from third-party sources, are trusted and up to date with security patches, right? So this is very, very important. You don't want people getting into your system, hacking away, and then you end up in a whole mess. Who knows what can happen, right? We see all these cybersecurity breaches that we've seen on the bug bite episodes. It's a mess. You definitely got to be careful with that. GitOps for configuration management. Adopt GitOps practices. Use GitOps principles to manage your Kubernetes configuration declaratively through Git repositories. Tools like Argo CD or Flux can automate the deployment and synchronization of Kubernetes resources, ensuring that your cluster state matches the desired state defined in Git. So this whole Kubernetes thing, it is massive, 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 but high stakes equals high reward. So definitely something that we're going to be diving deep into. Automate repetitive tasks. Now you're speaking my language. Use infrastructure as code. Automate Kubernetes clusters creations and management with tools like Terraform, Ansible, or Pulumi. I never heard of Pulumi before. This reduces manual errors, improves reproducibility, and simplifies clusters provisioning and maintenance. Automate CI/CD pipelines. Integrate CI/CD tools like Jenkins. We've seen a lot of Jenkins, GitLab CI, or Tecton, to automate the build, test, and deployment processes for your Kubernetes applications, ensuring faster and more reliable deployment. So that's going to be fun for us to get into. I'm really curious to see how Jenkins and Kubernetes are going to integrate with each other. Test and validate configurations. Use unit and integration tests. We've done a lot of review on unit tests and integration tests. Ensure your applications and configurations are thoroughly tested before deploying them to Kubernetes. Use tools like Kubernetes native testing frameworks like kubetest. That sounds very interesting. To validate your manifest and your configurations. Dry run and apply. Use kubectl apply that with the parameter of dry run to test configuration changes before applying them to the cluster, helping catch errors early. So that's going to be very interesting to see. Let's see what else we got. Clean up resources regularly. Remove unused resources. Regularly audit and delete unused or obsolete resources such as pods, services, config maps, secrets, and volumes to free up resources and avoid unnecessary costs. Automate cleanup. So use tools or scripts to automate cleanup of temporary or outdated resources, for example, completed jobs or old replica sets. And then we also have the documentation and knowledge sharing. Documents everything. Document your Kubernetes architecture, deployment patterns and policies, and best practices. Ensure that team members are familiar with the cluster setup and the rationale behind configuration choices. Encourage knowledge sharing. Conduct regular workshops, training sessions, and knowledge sharing activities to build Kubernetes expertise within your team or your organization. I think that this is a big point that not many people or not many organizations focus on, because if one person is siloed with all the knowledge, then let's say that person has to leave, or that person is out on some type of maternity or paternity leave, there is going to be so much headache trying to figure it all out. So I think doing this regularly, like having something scheduled where you can just talk about our configurations and just, sharing in general, like we do here every Wednesday, where we're sharing different concepts and different ideas, is very, very important. Not limited to Kubernetes, to just tech in general, right? Especially what teams are working on. Lastly, stay updated and engage with the community. Keep learning. Kubernetes is rapidly evolving with frequent updates and new features. Stay informed by reading the release notes, following the Kubernetes blog, and attending community meetups or conferences. Engage with the community. Join the Kubernetes Slack, mailing list, and other community forums to learn from others, share experiences, and stay updated on best practices and industry trends. So much to do. Very, very important stuff. So that wraps up everything. It was a lot. So we covered today the in-depth core objects and resources. We went through the advanced objects and resources. We broke down the challenges. We explored the best practices. So what I want from you now, give me some feedback. If you have some questions, things that I've missed, things that I got off, I'm sure there's so many things that I'm missing, but like I said, we're learning this. We're going to be getting hands-on to this Kubernetes stuff very, very soon as we go through our DevOps, most likely on Sundays. We're going to be getting to this very soon. I think we have left to get into the microservices, and then we're going to get into Kubernetes, figure out how all this stuff works. So I look forward to seeing you there. But with that being said, let's go back to full screen. Like I said, let me know what you thought. Give me some feedback. It was so much information to cover. I like and there's more too. So like between last week and this week, Kubernetes is so massive. I almost have a headache going through all these slides, But we're in it to win it. We are in it to win it. We are going to win. There are no days off. We're gonna run it up, right? I'm gonna wrap it up here. Thank you guys so much for tuning in. I really appreciate it. And if you can leave me any feedback, any comments, something that I need to go deeper on, let me know and we'll do that. Before you head out, do me a big favor. If you haven't done so already, like the video, share the video, subscribe to the channel, hit the notification button so you know every time we go live and drop new content, as well as go over to techcoachrough.dev, sign up for free, get access to our latest sprint review, as well as you can sign up for a tiered membership where I have exclusive content, how to use LinkedIn to network, how to use LinkedIn to research jobs, research companies, all of that good stuff. There's a lot of bad things wrong with LinkedIn, but the information you're able to get about companies, the people who work for those companies, and how to reach out to them effectively is gold. So check that out, techcoachrough.dev, as well as you can sign up for one-on-one coaching with me, where we can work together. We can strategize. We can help you level up your skill set so that you can win, because hey, we are going to run it up. There are no days off. We are in it to win it. We are engineered to win. But with that being said, I'm going to get out of here. Thank you guys so much for tuning in. This is Tech Coach Ralph with another episode of Software Explorations, Concept and Overviews. We just went over Kubernetes. We are out.